this problem we're given 5 complex numbers. A complex number is something that can be written a plus bi form where a and b are both real numbers. So we are to write our answer in both exact form and approximate form using our calculator and round to the nearest hundredth if necessary. So for the first problem, actually for all the problems, you need to know one property and one definition. That if ever you encounter the square root of -1 in mathematics, you are allowed to use its shortcut version. We name that I. Just by definition, we like to call this the imaginary number I. The other property you should know, that is, if you have the square root of two things being multiplied, say a and b, as long as one of them is positive, as long as a or b is greater than 0, they don't have to both be positive, but one of them has to be positive for this property to work, that can actually be broken into two pieces as the square root of a times the square root of b. So pretty much you can use this property anytime you want. The only time you wouldn't be able to use it if a and b were both negative. This property is not true. So I'm going to take the first problem here, square root of -9, and I'm going to break this into two pieces using this property. I'm going to break it up into 9 times -1. Certainly no one's going to argue the fact that -9 can be written as 9 times -1. Now, since one of these numbers is positive, I can use this property and say that this is equal to the square root of 9 and then multiplied by the square root of -1, just using this property going from right to left. Now we know that the square root of 9 is 3, and by definition the square root of -1 is I. So this may not look like it's a plus bi form, but indeed it is. In fact, I would think of 3i is nothing more than 0 plus 3i. So it turns out the real part of my complex number a would be 0, and my imaginary part would be b, which in my case is 3. So the answer to this one is simply 3i. So no need to go to my calculator because 3 is an exact number. So no need to round to the nearest hundredth, say. Now in the next one you're going to have to use a calculator to get a decimal approximation to the square root of 11. So let me show you that it starts out the same as the last problem, that you can write the square root of -11 as 11 times -1 and break it apart just like I did a few seconds ago. Break that up as the square root of 11 times the square root of -1 using this property, and again making sure that one of these numbers is positive, and it is. My a is 11, which is positive. So I get that this complex number is the square root of 11 and then times I, right? The square root of -1 is defined to be the imaginary number I. So I'm going to do this little line here to make sure that you understand that the I is not under the radical. In fact, I'm going to say or it can be written as equivalent form as I times the square root of 11. Remember that multiplication is commutative, that you can switch these around and still get the same thing. So I tend to write it this way so that it's very clear that the I is not under the radical. Notice that this is a plus bi form, that a again would be 0. You could think of it as 0 plus square root of 11i. So my b is the square root of 11. There's my answer, square root of 11i, and in exact form it was the square root of 11 times I. If you're going to write it this way, make sure to do this little line to know that the I is on the outside. Now going to my graphing calculator, the decimal approximation to square root of 11 would be, hit second, hit the x squared key, and you can see what you'd get by doing that. The second feature, or second function of this key rather, is the square root. So I'm going to type 11, and just because I feel the need, I'm going to cap off that right parenthesis, but if you didn't, you'd get to the nearest thousandths, remember. Oh, wait, nearest hundredth. Rounded to the nearest hundredth, that's the second decimal place, I would get 3.32. Because this digit is 5 or greater, I'm going to run this number up to 3.32. So I get 3.32i. Moving on to the third part, it's going to be much the same. It turns out that 18 has a factor that happens to be a perfect square, And perfect squares come out of radicals nicely. So for example, if you took the square root of 4, that comes out nice as 2. The square root of 9, for example, comes out nice as 3. And then just to do one more, for example, the square root of 16 is 4. So any number that's a perfect square, like 4, 9, or 16, have a property that they come out of radicals very nice, right? No decimals, just 2, 3, 4. So you might notice that 18 can be written with a factor of 9, meaning 18 can be written as 9 times 2, and then because of that negative again, you could put negative 1 there. So when I go to break this down, you could actually break it into 3 pieces. You could break it up into the square root of 9 times the square root of 2, and then times the square root of negative 1. So this property would apply with more factors than just a, b, and c, right? We could add a third one, and as long as only one of the values is negative, then the property would work. So the standard simplification of the square root of 18 isn't just the square root of 18. It would be that the square root of 9 is 3, and you'd leave that square root of 2 because that can't be simplified, and then you'd have I. So this is the standard simplification of square root of 18. The square root of 18 is the same thing as 3 square roots of 2. So I'm certain this is what was intended. So I'm going to leave this as 3 radical 2i, or if you were my student, I may have you write that as 3i square roots of 2, just to be clear that that I is not under the radical. Now, of course, I have to go to my calculator because I do not know what 3 times the square root of 2 is. So it is to the nearest hundredth 4.24. Because this digit here is less than 5, I need not round that up. So 4.24 would be the decimal approximation. Don't forget the I. So remember, I typed in this piece here, 3 square roots of 2, and I got 4.24 on my calculator. So let me box my answers here just for clarity. Here's my answer to the nearest hundredth. Here was my answer in exact form. This one here, I have 3 subtract the square root of negative 16. So that is going to come out as follows. You can write the square root of negative 16 as the square root of 16 times negative 1. And you could break that into 2 pieces then, because 16 is positive. As long as one of my 2 numbers is positive, you can break this into 2 pieces. And I would have 3 subtract, the square root of 16 comes out nice. Remember, it was a perfect square, it came out to be 4. And that's being multiplied by the square root of negative 1, which we know is I. So this is already in a plus bi form. In fact, if somebody were to ask you, you could tell them that a is 3, that's my real part, and my imaginary part b would be negative 4. I'd have to consider b to be negative, so that when someone put b in this general form here, that when you added a negative 4, you could think of that as subtracting 4. So anyway, my answer is 3 minus 4i, and I need not grab a calculator for that because it came out to be exactly 4. No need to round to the hundredths place. So you almost get to the point where you think of this as the 16 comes out of the radical as a 4, and if there's a negative 1 as a factor, it has to be multiplied, you could take that out as an I. The last one is not going to be too much different. You are going to write the square root of negative 3 as the square root of 3 times negative 1, and then you're going to split it apart because 3 is positive. Remember, only one of them has to be positive for this property to work. So when you split it apart, much like I did in the previous examples, you're going to write the square root of negative 1 as I. So this piece right here, at least, simplifies down to be the square root of 3i. So you have 4 plus, this came out to be the square root of 3 times I over 6. So this looks like it's simplified form, but if you look at it, you are to write your answer in a plus bi form, and it's not obvious to me that it's in that form yet. So what I'm going to do is do something that you may not be used to. I'm going to split the fractions apart. You may have learned in math, if you had 2 fractions with a common denominator, you can add them. This is the reverse of that. This is me splitting it apart. So notice that the division bar goes all the way across here, indicating that not only the 4, but also this is being divided by 6. So it's actually correct in math to split this apart as 4/6, and then plus, and this is also being divided by 6, hence the division bar going all the way across. And if you don't like that step, imagine going backwards. Imagine the way you're used to, where you have 2 fractions, and the fractions happen to have a common denominator. You were told going this way that you could add the fractions by just adding the numerators, and if you did that you'd get this, and then just copying the common denominators. So this indeed is that. All I'm doing is going in the reverse direction, and I like to call it splitting the problem apart into two pieces. Now you would want to simplify the 4 6 down to 2/3. So I'm getting 2/3 plus radical 3 over 6, and if you wanted you could put the I here, or what you might want to do is put it here so that it has that distinct look of A plus BI. So if I do it this way, if I line things up, it's obvious to me that the real part is 2/3 and the imaginary part B would be the square root of 3 over 6. So before I forget, I'm going to box this because it's my final answer. But don't forget to always go back and read the directions. I was supposed to give both exact form and an approximate decimal form to the nearest hundredth. So off the top of my head, I know, I'm running out of room, so I'm going to put it over here. I know that 2/3 is 0.6 repeating, but if you want, 2 divided by 3 is 0.6 repeating. So to the nearest hundredth, since this digit is bigger than 5, I'll round this digit up to a 7. So that's 0.67. So let me do second x squared to get a square root. And it was the square root of 3. And then you're going to want to close that parenthesis so that it knows that the division by 6 is not under the radical. So let's see here. I get to 2 decimals, since this digit is bigger than 5, that this is going to be rounded up to 0.29. So I'm going to go back here and put 0.29 and then the I here. So in decimal form, here is my answer.